Hello, algebra students. We are looking at 5.1, factoring integers today. And if we are factoring integers, we need to know all about factors. Factors are numbers that are multiplied together to get a product. And integral factors are factors over the set of integers, meaning no decimals or fractions. So you have integers are your whole numbers and their opposites. So a way to refer to that as integral factors. So when we are looking at factors of the integer 20, we want to list all the pairs of the factors of the integer 20. So thinking about things that you can multiply to get 20, so the factors to kind of make sure you're getting all the factors, you want to list them in pairs. And I will typically list them in pairs so that I start with the number and 1. And notice I'm leaving space in between when I do this list. This is not the only way to do it, but I like to work through this way so that I can meet in the middle. And sometimes it leaves some extra space in the middle, and that's okay. But 1 and 20 will give you 20. 2 and 10 will give you 20. So again, just kind of noticing that I'm just going up from one integer each time. And then I would try 3. Now 20 is not divisible by 3, so that doesn't work. And then I would just go to the next integer, which is 4. And 4 of course goes into 25 times. And then what we see is, okay, if I were going to try the next integer up from 4, it would be 5, and that's already there. And so I know that I'm finished and I have all the positive factors. Now, if we're looking at integral factors, then I have to also look at those opposites. So if I'm listing all the integral factors, I would then list the opposites of all my positive factors. Okay, so the next one is 64, your turn. I'd love for you to pause the video, list all your pairs of factors, and then check in. All right, so just checking in then, we need to look at the pairs of factors of 64. So going through that list, I would list 1 and 64. And then I think through to the next integer, which is 2, and 64 is divisible by 2, goes in 32 times. I would think about 3. Okay, 64 is not divisible by 3, so I go to the next integer, 4. And 64 is divisible by 4, it goes in 16 times. Then I would think through 5, not divisible by 5, doesn't end in a 5 or 0. 6, I would check that, doesn't work. 7 doesn't work. And my next factor would be 8. It's 8 times 8 that gives 64, so I don't need to list that twice. And because my next number is 8, then that value, I know I have all the values when I get to that doubling, that squaring. I could check 9, 10, 11, 12, 13, 14, 15. None of those work. And then the next digit would be 16. So, or the next integer would be 16. And so I know I have all my positive factors of 64. Now again, if we're listing the integral factors, I want to then go through and list my opposites of those positive factors. An integer greater than 1, whose only positive factors are 1 in itself, is called a prime number. And when we express a positive integer as a product of primes, that's called prime factorization. You have done this before with factor trees, so we're just kind of reviewing the factor tree process. And then we're going to take it a little bit further. So we're just looking at positive factors here to get the prime factorization of 76. And so we would just take our 76 and think of two things we could divide by. It does not matter what two factors you start with. If you continue correctly, no matter if we start with two different factors than each other, we should get to the same end result. But it's not immediately occurring to me what 76 would be divisible by, except that it's even. So if it's even, I can always try and divide by 2, of course, that will work. And 2 goes into 76 38 times. Now 2 is prime, so I will continue to just bring that down. And 38 is even, so I know that that is also divisible by 2. And so I divide that, and I get 2 times 19. So if I carry down the primes like 2 that I've already gotten to prime, then what happens is each row should remain equivalent, like that row is equal to 76 and this row is equal to 76. It's a good way to check your factorization as you go. And then also if you're carrying things down, when you get to the bottom of the tree, you have your prime factorization at the bottom. And so my prime factorization of 76 is 2 times 2 times 19, which we know we can write exponentially in exponential notation as 2 squared times 19. All right, so next one is your turn. You would try and find the prime factorization of 180, and then I'd like you to check in on Edpuzzle, and then we'll continue with checking those values. All right, so I'm starting with 180 as you are. And again, we might not have started with the same two factors, but hopefully at the end we'll have the same prime factorization. I notice that 180 ends in a 0, and so I know it's divisible by 10. And so I can say, okay, that's 10 and 18. 10 is not prime, so I can break that up into 2 times 5. 18 is not prime, so I can break that up into 3 times 6. Again, there are other choices there, but we should end up with the same results in the end. 2 is prime, 5 is also prime, and 3 is also prime. So I'm just bringing those down to the next level. And then 6 is not prime, so I can further break that down into 2 times 3. Once I get to the bottom of that tree, I should notice that I have all primes and I'm finished with my factorization. I just want to write it in exponential notation. So that is 2 times 2 times 3 times 3 times 5. Notice I'm trying to write those in, ascending order. So I'm just like putting the smallest factors first. And then, of course, I can write that in shorter in exponential notation. That is 2 squared times 3 squared times 5. The greatest integer that is a factor of all the given integers, so when we have more than one integer, we want to look for the greatest thing that will go into all of them, and that is called the greatest common factor. Again, shouldn't be a totally new concept to you, but we are going to take it a little bit further algebraically than you may have seen before. So writing out greatest common factor there, and then we don't usually write that out. We just usually refer to it as the GCF. Now we want to find the greatest common factor of 96 and 64. And so one way to approach that is to go use the prime factorization. Now you could just go through and try dividing 96 and 64 by things to find the biggest value. That certainly works. It's a little more unreliable the bigger number you get to, because you've got to try a bunch of different things. And once it involves variables, that can get more difficult as well. So we want to show you this factoring method so that you can use it for really large numbers and that you can use it when you're dealing with variables. And so we're going to do the prime factorization of 96 and 64. So 96 I'm going to break down. I know it's even, so it's divisible by 2, and I go through that. Okay, that's 2 times 48. 2 is prime, so I just bring that down. And 48 is even as well, so I can break that down into 2 times 24. My 2's are prime, so I just continue to bring those down. And 24 I can break into 2 times 12. Again, my 2's are prime. And my 12 I can break up into 2 times 6. And bring down my 2's. And 6 I can break up into 2 times 3. So once I've got all primes there, I want to list those out. So I've got 96, my factors are 2 times 2 times 2 times 2 times 2 times 3. And, oops, there we go. And then for 64, I want to break into its primes. And again, 64 is even, and I know it's divisible by 8 as well. I know that it's 8 squared, so I'm going to try and break that up by 8s here. And that is 8 times 8 is 64. Now 8 is not prime, so I can break that down into 2 times 4 and 2 times 4. 2's prime. 4 I can break into 2 times 2. 2 is prime. And 4 I can break into 2 times 2. So 64 is just a series of 2's. And I'm going to go down here to the bottom of my page and list out 64's factors. So I have 1, 2, 3, 4, 5, 6 factors of 2 there. Oh, my goodness. There we go. 1, 2, 3, 4, 5, 6 factors of 2. So that was the prime factorization of both those numbers. Now to find the greatest common factor, or the biggest thing that will divide into both of them, I need to look at what they have in common, and I want to combine all the things they have in common. So they have 1, 2, 3, 4, 5 factors of 2 in common. And so my greatest common factor would be those 5 factors of 2. And so my greatest common factor is when I multiply those 5 factors of 2 together, which you could write as 2 to the 5th, and I get 32. So the greatest common factor is 32. So again, prime factorization, and then you see, okay, what do they have that matches? What do they have in common? And you combine those together. So that gives you the biggest thing that will divide into 96 and 64, which is 32. Okay, your turn on the next one. You're going to try and find the greatest common factor of 132 and 220. Check in on Edpuzzle, and then we can check back here and I'll show you the process for finding the greatest common factor just in case. So I've found the prime factorization of 132 and 220, and you can see that 132 is 2 squared times 3 times 11, and 220 is 2 squared times 5 times 11. So again, to find that GCF, I want to look at what do they have in common, and then that I would combine them through multiplication. So they have two factors of 2 in common, and a factor of 11 in common. And so their GCF would be 2 times 11. And if I multiply that out, 2 times 2 is 4 times 11 is 44. So the GCF of 132 and 220 is 44. Hopefully that's what you got. If you're not sure where those values are coming from, please make sure you bring your questions to your algebra teacher.